Good day, everyone. So, our topic is all about concepts of probability and statistics hydrology. So, under this topic are basic probability, return period, design storms, regression analysis, and standard error of estimate. So, in this video, we are going to briefly discuss statistics, probability, and return period. And you may ask why we are doing statistics and probability in hydrology. So I am assuming that many of you have taken some sort of probability statistics and you know something about how to calculate probability, what probability distribution are, and so on. So in this video and some other videos that I am going to do related to statistics and hydrology, I will just relate the statistical part to how we are going to use in hydrology. So again, just to refresh you what is statistics. So statistics is about making inferences about the population of a random variable from a sample of that random variable. Population, sample, inferences, and random variable. So you may have heard all of this before. So we will just see how that is used in hydrology. Next is extreme hydrologic processes can be considered as random with little or no correlation to adjacent processes. Thus, the output from a hydrologic process can be treated as stochastic. So, hydrologic process in a deterministic way. So what that means? It is we start with rainfall and we know how much of that water, or at least we try to estimate how much of that water infiltrates into the ground, how much of that gets evaporated, and how much of that becomes runoff. So again, as I said this earlier, why we do probability and statistics in hydrology. So at this moment, at least we're interested in frequency analysis. So it means we are looking at from the hydrologic design point of view, what is the maximum discharge a structure needs to handle. Probabilistic treatment of hydrologic data. So a random variable x can be described by a probability distribution which specifies that the chance an observed value of x will fall within the range of x. So this capital letter X stands for a random variable. In this slide, as you can see, it is a time scale. So I'll just divide this into 3 parts. So what you see here on the blue line is just time in each circle represents 100 years. So 0, 100, 200, then this 500 in the middle, and so on. And then if you see a flood event, so you can see that flood events at the top of the time scale. So if we go with the definition, 100 years flood happens after every 100 years. So this is what happened in our nature. Showing this second illustration, what you see is we still have the same number of events, but they are taking place at the first half. In this third case, we have 10 events that are evenly distributed over a period of 1,000 years. So the technical definition of a return period is that over a period of long time depending on your return period. So return period is equals to 1 over EP, or EP is equals to 1 over T. So take a look at the statements below. For 100 years flood, we say that there is a 1% chance. So this 1% is 1 over the return period, which is 100. Next is 2 years flood. There is a 50% chance. So 50% is again 1 over T. So T in this case is 2. So instead of saying 2 years flood, we say a 50% chance that is flood will occur every year. So that would be all, and hope you understand my discussion. Thank you for listening.